My name is Christian Krabbe, and I'm a concept lead here at B&O, and I'm responsible for all our speakers. And I've been responsible for the BeoLab 90 internally at B&O to run the design process, and also working together with Andre in controlling the design development. So BeoLab 90 is without comparison the most exciting project that I've been running here at B&O, and I've been here for many, many years. It's been super challenging, but it's also been super rewarding. The good thing about having a good challenge is that the reward when you succeed is so much bigger, and we've had some great challenges. But we've also been rewarded, and we'll talk you through this a little later. So, what kind of thing is a BeoLab 90? As Jeff told you this morning, the special thing about BeoLab 90 is that we have speakers everywhere. That means that there's not a front and a back anymore, so we have to take care of everything. Normally when we do B&O speakers, we never make an ugly backside. So even if it's called a backside and a front side, we take care of everything. But here we had some special requirements, which was that we had to fulfill all the acoustic requirements as well, all the way around. So this was completely different to what we normally do. Another thing which was very different was the amount of power. We're talking about more than 8,000 watts. And watts means heat. So we had to somehow get rid of all the heat while still having a really, really beautiful design. Another thing which is of course always categorizing a B&O product is that it has to be striking and it has to be beautiful, and it truly had to show Bang Olufsen's way of looking into the future of sound. So this should point in the direction where B&O wants to be when we're talking about the future of sound. One of the big challenges here as well is the size of this product. When you look at B&O products, they are really compact, so we get big sound out of small cabinets. Here we're talking about a big speaker by B&O terms. So we also had to get our minds around to doing something this big that had to fit into people's homes and really look beautiful in there. And the last thing was the deadline. This was to be launched on Bang Olufsen's birthday in November.
No chance to move that.
And there was no way we could change that. So no matter what happened, we had to be finished by November this year. So that's all the boundaries, and somehow we had to get Andre started. So we made a brief for him, and I'll read it out because it's actually not that complicated. So what we told Andre was that he should create the most lifelike reproduction of sound so far from Bang & Olufsen with regards to dynamics, clarity, and sound pressure. It should tingle your finest senses and strike your guts at the same time. And it should intelligently adapt itself to any imaginable use case. So that was simple, right?
Yeah, a simple brief for the most complex product we ever worked on as well. Luckily, this brief came together with a sound demo to that wooden box over there, so that we could experience what it means to move sound in a room and to experience what it means to direct it, to sharpen it and to open it and all that. And when we listened to it, it was quite certain for us that our main task was to come up with an equal, unprecedented design, an idea which fits to that kind of experience. But how to get there? So there was that tiny information from a customer research we picked up, where people were asked what's magic, what makes products magic, what makes them fall in love with products. And there was one lady who talked about her channeler in the entrance hall, and she said she loves that product because it's different every day. Every time she looks at it, it's different. The light makes it changing and the crystals move and all that. And we said, okay, that would be a nice approach for a speaker like that, which also changes all the time. And so that was one of the targets we set. We should come up with an idea which can change, which can be explored in a new way every time. beside that, we knew we had to build up a structure for that piece. And as we are at Bang Olufsen, it was for sure that we would do that with aluminum somehow at that point. And we looked in all these skeleton, these polygonal structures, you know, from nowadays architecture, where we could say, okay, so we could build up a structure in a relatively lightweight, and and can also build a tall structure like we would. In addition, we knew we had to deal with fabric, because as we knew we had to distribute the sound 360 degree. We needed a lot of acoustical transparent windows all over. And our approach is always not to work additive with design elements. We want it in one holistic way. So that's why you can see in our first concept phases that the selected designs for our first presentations are dominated by fabric. And we were searching for ways, how can we give structure to fabric? At that point, one simple principle of German architect Frei Otto came to our mind, which is shown in that roof construction he did. He's famous for the roof of the Olympic Stadium in Munich, for example, so lightweight roof constructions. And that's really the minimum structure you can get for maximum tension. So what you need is just 2 lower points and 2 upper points, and you define the whole tension and the whole curvature of that surface without any support in the middle. In addition, this shape makes exactly that dancing of light we described there, so that you can, when you move it around and you have a nice reflective material, you will see that the light moves over that surface. So that was our first task, our first challenge we gave to Kresten and his team in that development.
Yeah. So what is special about this, except that it's beautiful, as Andrea is saying, is that it actually also solves the problem that we had, or the task that we were given from acoustics. Because what we needed was a fabric that didn't need a carrier on the backside. Normally, when you do fabric fronts, you would have a plastic carrier or a wooden carrier, and then you would drill holes in there, and then the sound would come through there. But if you're talking about a speaker like this, which is really, really high-end, it would be like tuning a race engine, and then you put a banana in the exhaust pipe. It wouldn't work, and the acoustic guys just said no way. So actually, even if it was a task for us to solve how to do this in manufacturing, it also helped us actually defining the solution for this. So our task was actually to find out how do we create something here which is strong and maintains the tension of the fabric, and that can be mounted onto the speaker in a very elegant way. So we solved it by doing this with very, very thin steel frames, and then we wrap the fabric around, and then we attach it to the steel frame here. So we found a good solution both for design and acoustics.
Exactly. So, but if you have a look at our first concept phase, that wasn't the only design idea we came up with, but it was the one which was selected. And if you look at the 5 concepts we came up with, it is funny when we prepared for this day and we look back to the models we prepared for the first presentation. So obviously the ugliest one and the most unfinished one was selected to be the one we will build on this whole story. But I can tell you why. So it's because it's exactly like that. It was, from the beginning, it was clear that this will be the most far out and this will be the most challenge. And so that's the right
all the allocation of resources, and actually found the whole idea of this huge project. And that's a beautiful thing about working with B&O, that if you have the right idea and you have the potential, then you're actually possible to do something extraordinary from almost what, looking back today, seems like a bit of a risk, you could say.
But it was added by a strong promise that we will improve.
Yes.
Okay, beside that, beside creating the conceptual, aesthetical concept for that, we also work on technical, challenging the brief from technical perspective. Because when you look at that box over there, it's very low, it's very fat in the bottom. You have to deal with big steps from woofer to mid-range area. So quite hard to get a nice aesthetical shape around that. So what we did is that we challenged the brief with these one-to-one scale samples and always questioned in team sizes like that. So what's possible from acoustic point of view? Because we knew we won't do any compromises in acoustics for that project. But what's possible to create an aesthetical concept around it that is sufficient for all of us?
At this stage, with all this, we had to go out and find new suppliers, and we succeeded luckily. So we have a Danish supplier for the top frame here, who are an expert in bending steel and putting it together, and then we selected a German supplier for the fabrics delivery and also for mounting the fabric. And it's a partner that we're working with in automotive as well. So it's a known partner to us, so we knew the quality was the best we could get, and they actually accepted to take this challenge with us. So that was lucky, almost, that we found these guys.
But by all these changes, something interesting happened. So we had to change the skeleton structure to a structure that we have the rough aluminum base on the inside and have that delicate frames on the outside. By the same time, we compressed this area by switching to smaller woofers in that area and placing one fat woofer down there, which offers the same performance like we had over there, but even more on axis, and we could get more slender, more compact. And by introducing that head, where the top crown is a repeating of what you find here, telling the frequencies you distribute in the certain layers, we suddenly created a product which became much more interior-like than the first draft we had. So where this is much more focusing on the skeleton structure and becomes much more exterior design, we changed it to a more interior-like product, which was more warm, more welcoming, and we thought, okay, that fits it even better. The bad thing was the volume wasn't enough anymore. So because we had to pack all that electronics in the black box over there in that product as well, beside the volume you need for the base cabinets. So we had to close the bottom, and by making the product even more interior-like and also grounded, we decided to add these wooden panels. The next challenge for Preston.
Yes. What is so great about the panels down there is that they also tell the story about the Danish craftsman's history within furniture and wood treatment. That's a great thing. The difficult thing with wood is that it's a natural material. So if you expose it to heat, or to cold, or to moisture, it actually starts to move around. And when you're having super exact steel beams that are not moving at all, and you have a living material next to it that's moving around, you have a great challenge. And this one we've been struggling with all the way through, and we're still struggling with this. But there is a hard deadline, so so we will get it fixed. So, but that's been actually we thought that would be the easy one, because how hard can it be to do some plywood? But as soon as you apply it this way, where you have something you can compare it to, then it's a living material.
Put a piece of plywood in a defined frame is a very hard task.
Nobody else does.
That's what we learned.
So the wood makes it bigger, or what's the purpose of the wood?
Due to changing humidity, and it starts to bend. So and that's something you have to control.
And why did you want to have the wood?
Yeah, if you look at this one over here, it's very open in the bottom. right?
Yeah.
What happened was that the hardware guys came with this
yeah,
bastard
the
over there.
electronics to go
Yeah.
And we
to hide them.
simply, we wanted to create something which was slimmer and more elegant than this one.
Yeah.
So we needed more volume. And the way to do that was actually to bring more volume down towards the floor. And then we added the, as I said, the wooden panels to make it more interior-like. So what we realized in the end and found out was that if you mold this in aluminium in one piece by the gravity aluminium process, you could actually create a monostructure in there, which is super, super stiff. And it gets rid of the heat in the most efficient way. And also you don't have to have any joints in there. If you did it in other materials, you would have to screw it together and seal it everywhere, and you would have problems with rub and bust and all kinds of other problems.
No room for mistakes.
No room for mistakes. And here you have it all in one. And actually the tooling for this one is, it's actually so big that the supplier had to buy a new forklift truck to move it around in the factory. The one tool part weighs 4 tons when they buy it, and then they remove 2.2 tons afterwards to create the cavity in here. And that's one part of it. Then you have the other part, and there are 4 parts going into that. So it's extremely advanced, and they've never done something in this size before. That's a new supplier as well from Denmark as well.
And as you mentioned in the beginning, we also had to get rid of the heat.
Yes.
With all that amplifiers inside, and therefore the aluminum material for sure is the best one because it can transport the heat.
Yes.
And as you can see on the back side, we have that baffles where we have all that cooling fins on where the amplifiers are mounted on, and they are also assembled to the project in an intelligent way so that it is easy to maintain the product and easy to assemble it as well. As you could see in Factory 4. Yeah, last but not least, to show the capabilities of aluminum craftsmanship, where Bang Olufsen is famous for on the outside, we decided to have these 3 crowns, which, as I said, which correspond to the wavelengths you send out in the layers. And usually, and I think every other company would have done it like that. You would bend a steel or an aluminum wire and weld it at one point. But we said, if we really want to tell the story of 360 sound distribution, we shouldn't implement a front or a back to the product. And to have a welding point means we would put that probably to the back. Therefore, we asked if it could be possible to have it in one piece, because we thought about maybe there could be a way through to do that. And
that was
another challenge. Another challenge, but I think one of the impressive ones.
Yeah. So actually, what Factory 5 said that when we asked them was, well, it's possible, but we don't want to do that. And we can go over here and look at why. Because the way you would normally do this would be that you have a sheet of aluminium in this thickness, then you would stamp it out in here and out there, and then you would throw all this aluminium away and all the material around there. And we don't do that at B&O. We have to act responsibly in the world, and we want to do something which is intelligent as well. The other one is close to being, I'm not saying the word, but it's not a brilliant way of doing it, right? So we had lots of meetings with Factory 5, and actually Martin Rasborg, who's a software guy, unfortunately came up with a brilliant idea, which is the one that's actually the one you saw in Factory 5 today, is where you start out with something like this. And it actually allows us to have the best alloys you can get. And then what we do is we mill it out like this, right? So instead of having all that waste, you only have this little bit in the middle. And then you form it from there on, as you saw in Factory 5. So as soon as you have this, you pull it into this shape, and then you're back to where it should be, right? So this is brilliant. That was a great idea. I'm so sad it wasn't mine. So in the beginning, the first prototypes were done like this by hand to prove that the process was right. And then the rest is history. We made it.
Today you need about 15 tons
Yeah.
to get that straight as it is.
Yeah.
So, and if you saw the process, and it always feels like, for me, it doesn't look like they work with aluminum. So it is like, it's like a piece of rubber they bend in form.
Yeah. That's a great thing about Factory Fire. They like good challenges as well.
Yeah.
That's a nice supply. Yeah.
So standing here in front of the assembled product, just a few more words. So if you look at the top, there are two main reasons for why the top looks like it looks. The one is that we took some elements from Bang Olufsen speakers. So for example, the BeoLab 18 has a similar shape on the top, where you can have also a very, very nice light reflection, and it makes that product family to all the other products. And in addition, we implemented a light ring, which shows how the speaker is distributing the sound. So if you have the on-axis mode, then you would see a very, very sharp line in the center. If you start to spread it, you will see that there is a fade out of light and that you have a more smooth distribution. And you will also see that you move the sound, if you control it with the app, from place to place, that you will see that the light moves with it.